Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, welcome to another exciting episode here at IT Pro TV. I'm your host, Mike Roderick, and today we're doing our CompTIA A+ 901. And in this episode, we're actually doing a part 2 on motherboards and components. So if you missed part 1, make sure you go back and check that out. We're going to dive right back in, pick up where we left off, and here to do that with us is Mr. Wes Bryan. Welcome back, Wes.
Hey, Mike, thanks for having me back. Yep, that's right. We had a lot of components. Well, we have a lot of components that we need to talk about. So, like Mike said, that's why we're in a part 2. In the first part, we talked about some of the components that you can see on a motherboard. We talked a little bit about things like your RAM slots, expansion slots. We talked about some of the chips, if you will, the computer processors, if you will, that are on the motherboard called the chipset. And if any of this doesn't seem familiar with you, like Mike said, go back and watch part 1 and then come back to part 2 here.
All right, Wes, we talked about like Northbridge and Southbridge, a couple of the chips, as you said, that are typically integrated on that motherboard. But there's one big chip on that motherboard that we haven't talked about yet.
Yeah, that's the one that you never want to forget about. Apparently, my memory needs upgraded. But one of the things that we have to also talk about is the CPU. All right, the CPU is the central processing unit. You might hear it called the processor. I've heard it called microprocessor before. I don't really hear it called microprocessor too much anymore. That actually goes back to the earlier days when a guy by the name of Gary Goodall went to Intel and he said, you know, these things are more than just controllers. They can actually process information, so they called them microprocessors in the earlier days. But what we want to look at is the connections specifically that they make to the motherboard. We'll talk a lot more about CPUs and kind of dive into what they are and some of the different types and characteristics. But for the motherboard itself, every motherboard is going to have one of these sockets where we install really the brains of the operation. So if we can take a look here, and like you've seen in the first episode, we've got a few different boards here just so you guys can see that, you know, they come in all different shapes and sizes. And well, one of the things that you also have to keep in mind is they could have different socket types, all right? Now, what you don't see on this one is the CPU socket, right? Because we have a couple of things that are attached to it, right? We have the processor that's set down on it. We have this little metal fin type thing, like kind of looks like a radiator called a heatsink and then a fan. But below that, we have these type of sockets. Now, Intel's a little bit different, and we'll get into the specifics here in a second, but this is a CPU socket, and it's where you install, if you will, the CPU itself. Now, you're looking at two of the same types, and if let me go ahead and put this board a little bit closer here. You can see that there are little openings right here, and these are where the pins on the bottom of a CPU are going to make contact, and more importantly, when we install it, it'll make that electrical connection to the motherboard that allows the processor to process that information. Now, this is something that is called a PGA socket. Now, Mike, I know you're a golfer, but unfortunately, we're not talking about the Professional Golf Association on this one.
Oh, dang it.
We're talking about something known as a pin grid array, all right? And a pin grid array is the type of socket that has, well, the pins are on the bottom of the CPU, and the openings, if you will, or the ports on the socket are the openings that the pins will be inserted to. Now, you might notice that in this one, there's this little handle right here, and this little handle is actually a really clever design. All right, in the earlier days, you didn't have this handle. When I say early days, I'm really talking about some of the very first PCs that were out there. They didn't have this. Well, I want you to understand that when you put an electrical current on a CPU, it's going to get very, very hot. Well, what happens when you turn it off? Well, it's going to cool down. So you have this expansion and contract, expand and contract and expand and contract because of the heating and the cooling of the CPU. Now, the problem in the early days was the fact that that would cause something known as chip creep. Chip creep just basically means that, quite literally, this CPU that was installed in the socket could walk its way out, grow legs, and, I don't know, take a break for the day. But it would cause problems, right? Because it would move its way out of its socket, and then again, we're not making electrical contact, and all kinds of problems can happen, short-circuiting, even damaging the CPU. The other problem that you have is if you look at the socket itself here on this motherboard, these pins, right, in this case, the openings are very, very small. And it's very easy that if you were to install a CPU, you could potentially bend the pins, all right? So they came out with this unique design that actually moves, I don't know if you can see in relationship to my finger there that the socket is actually moving from side to side. And what it would do is it would open up, what it does is it opens up this socket and it allows you to just drop the CPU based on a marking that's on the socket itself, and it's also a marking on the CPU, tells you how to align it so that you don't get it, you don't install it wrong, right? Because that would definitely cause pin bending. And you could literally just drop that in there and just shimmy it a little bit and you'll feel it drop into place. And then you take this latch and you push it down, right? And you'll notice it moves it forward, and those pins, they get grabbed onto, right? This is what's known as a ZIF socket, and it's been what we've used for a very long time now. It's called Zero Insertion Force Socket. So I want you to know the ZIF socket is the one that essentially will protect you from things like chip creep, again, the socket, or basically the CPU walking out of its socket, and it also helps to prevent pin bending. Now, in the AMD world, they're the ones, Advanced Micro Devices, AMD is the two major CPU manufacturers right now, and have been for a long time. They're the ones that adopted the PGA, all right? But Intel, they went a different route. They went with something known as an LGA, and they still do today. They have for a long time gone with what is known as a land grid array. Now, I've got a picture because a land grid array is considerably different here. In a land grid array, you're going to notice that the electrical contacts that are in the CPU or in the socket, they're like a bed of nails, right? So it's the electrical contacts here are actually kind of pins that are facing up, right? And what we do is we essentially still have that same little lever. You'll see a latch, and that latch folds down on top of the CPU, and then you pull this lever, and what it does is it takes the surface of that latch, or the surface of the closing point there, and it presses it down. Now, on the bottom of an Intel-based CPU, you just have these flat contacts, right? And what they do is they make the electrical contact is made with the pins, right? The grid array here that is down in the CPU itself. All right, so a little bit more alphabet soup here, but you want to know the two major types of CPU sockets that you can find on motherboards. And they really are vendor specific, right? When we talk about CompTIA and A+, and a lot of the other CompTIA exams, we talk about vendor neutrality. This is not a vendor neutrality. They one went one way, the other one went the other way. Intel, they stick with the land grid array. The AMD sockets, they're going to be the PGA sockets. So know those two different types and know what their differences are, because you don't know. They might give you an exam question that maybe gives you a picture and says, what type of socket is this? And you're going to have to know that and know that they're specific to each manufacturer.
Very good. But performance-wise, there's no real big difference, right? It's just how does the processor actually make contact with the motherboard?
That's right. It's really how the processor makes contact, and then we get into the whole Intel versus AMD. And I don't know if we want to go there on that one, because some people like and are very product, I don't know, they like Intel, and some people swear by AMD. So ultimately, Mike, I would say no, it's not really a performance thing. It's like you said, it's just how they make the electrical contact with the motherboard and the CPU itself.
Very good.
All right, now the next thing I want to talk about is something that you don't really see on these boards at all, and that's something known as a reset button. And a reset button, you find it a lot on the newer boards, and you can find too that this is also part of the case itself. Depends on where it's located, and a lot of times you'll have two of these switches. The ability to recycle the power all the way and restart the machine without having to hard boot the entire machine. And that's something known as the reset button. Sometimes you can push that on the front of a case. You'll see a little small button that you can reset, but a lot of these motherboards actually have a button right on the motherboard itself that you can push, and it restarts the system. That's called the reset button. So it might be something that you have on the motherboard. I know mine's got that on. I've got a Gigabyte Asus type, or not Asus, but a Gigabyte type board, and it's got that. But these here, they don't. I can't actually show you that. Keep in mind, it could also be on the case as well.
Very good.
All right, so what else do we have connected to the motherboard? Well, we got a lot of stuff. The next thing that we're going to talk about, and they call out on the exam objectives, are fan connectors. And there are a couple of different types of fan connectors, and I want to kind of mention them here. One that is on the motherboard, one that is not, and I want you to know the difference and why you might use one over the other. All right, I've got a couple of fans here that we have set to the side here, and if we can take a look at them, you got a couple of different connectors, right? You'll see in our hard drive section that we talk about the old traditional Molex connectors, and these go back to the days of like the early days of like the parallel ATA connectors, the old hard drives, right? Well, they're still used inside of your computing environment because what they do is they connect to these system fans. Now the good thing about this is you can take a single power plug coming off your power supply unit, and you can daisy chain a lot of these on there. Okay. But there's a limiting factor to these. A lot of times what you don't get is variable speed, and you don't get some of the monitoring and not diagnostics, I guess more monitoring than anything that we talked about in our BIOS section. To do that, what you need to have is one of these. They're still a Molex connector, but they got a funny name. It's Molex KK. I don't want you to worry about that. It's just a family, a style of connectors, and they can be all different types of connectors, but primarily what you see inside of your computing environment is a 3-pin or a 4-pin. If it's a 3-pin, then what it means is that you can't really monitor it. You'll have your positive, you have your negative, and then I believe you have your ground here. If you see a 4-pin, then what that means, same thing, you got your positive, negative, and ground, but then you have a 4th pin for things like monitoring. And they usually plug in, you'll see, well, this one's completely different here, but you'll usually see a little header on the motherboard that we can plug these into. Now it's important to understand that when you plug the system fan, this is the CPU fan, these are called system fans. When you plug these into the motherboard, this gives you the ability, or the motherboard, the ability to say, okay, if I've got a thermal temperature sensor that's basically telling you what the heat is, detecting what the heat is, if I see that heat rise and the temperature start to go up, with that 4th pin, it can send a little bit more electrical current, not only monitoring it, but send a little more electric current to ramp up the RPMs on the CPU. And again, these are you can find them all over the place. Let's see if I can find one on this motherboard. Sometimes they're hard to find. And you know what? I am not seeing one. There's a CPU fan, and that's actually, you can see the 4-pin right there. I know it's kind of hard to see. But that's a little 4-pin Molex connector. And again, this gives it the ability that if it detects that there's a lot of heat and it maybe needs to increase the cooling, if you will, it will ramp up the RPMs within the system unit itself. Basically assisting the cooling. Oh, there's one. Here we go. Here's a system fan header right here. It's kind of hard to see, but you can see SYS_FAN there for system fan. So what we would do is we would take one of these here and we would just plug it right into here. And there we go. We've installed one of the system fans, and then what the system fan does is it typically sits in the case and it pulls cool air inside of the case itself. Well, depending on how you have your case set up. Sometimes these can be a push mechanism, sometimes they can be an exhaust mechanism. So basically based on what your case might support. So those are something to keep in mind as well. Again, if they're integrated into the motherboard, the big thing with those that I want you to take away from this is the fact that the motherboard itself, it can detect the RPMs. You can even see in the monitoring software in your BIOS that it'll tell you the RPMs that it's running. I know mine does that. It says, okay, well, my CPU fan is running at 2,900 RPMs, and it sees the heat start to rise. I've seen where I've gone in there and it's like 4,000 RPMs, and I'm like, well, I think it's time to blow the dust out of this case because the cooling system is having to work really hard. So it does variable speed, and it also gives the motherboard a chance to give you a little bit of information back on the current, the current status of that fan as well. The other thing that's really great about these two is it detects system failure, or excuse me, fan failure. Right? You can see it a lot of times that it might even throw a warning. If in your BIOS, sometimes BIOS or UEFI platforms, they support fan failure warnings. Be careful with that because when a fan fails, oh, you're going to get warned all right. So are your neighbors next to you. It basically gives off this high-pitched alarm. So I made the mistake. I have quite a few system fan headers. You might call those the connectors on the motherboard. You might hear them called headers. And what I did is I turned the alarm on, but I didn't connect one of the fans. So it thought it was a failure. And the moment I turned the computer on, so you might not want to turn that alarm on if you're not going to populate. And that means, again, jargon for installing all the system fans across the motherboard itself.
Very good.
All right. So the next thing, we've got what are known as top or front panel and top panel connectors that we need to look at inside of our motherboard. And these are this is an interesting concept because what is a front and top panel connector. Mike, I don't know about you. Do you see any panels on this motherboard anywhere?
I was going to say, you know, Wes, like my case at home has some connectors on the front, but I don't see how they're going to get to the motherboard.
That's right. Well, the front panel and top panel, I want you to think, for instance, I want you to think of your case. This really relates to your case and the connections that your case, your tower, right, the exoskeleton of the system unit make to the motherboard itself. And in fact, let's see here. This one, okay, so we got this right here. Let me turn this around a little bit. Did I get that in the camera there? It's over here. Yeah, there we go. So it doesn't look that glorious, right? It's just a little small connector right here, right? And you can see a series of pins. Now, I will tell you that every one of these are kind of unique to each case that you have. And on the front of your case, you might have seen things like a hard drive drive activity light. Right, when you turn on your computer, you see the little red or green or blue, whatever the color might be, you know, and you can see that light flickering on and off. That's a drive activity light indicator. It lets you know that the hard drive's running, or maybe it's red, and that tells you something's bad. Maybe the hard drive isn't running, and you got more problems than you know. But it can also do things like the power light, right? When you push the power on the front of your computer, that light, a lot of times you'll have a light in that power button that comes on and it'll let you know, hey, we got power to the computer. It also connects things like your audio. If you've got those little, what are they, the 1/8 inch, 3.5 millimeter TRS jacks, the audio jacks on the front of the case that I plug my headphones or a microphone into, well, that's where you connect those connections from the case to the motherboard, and it allows you to use those headphones and those microphones. Could be USB. All right, now on the motherboard here itself, let's be careful. Let me show you this motherboard again down here. Notice that we have some USB connectors that are on the back of this motherboard and a stack of them right here. Well, those are integrated, right? That's the I/O ports, and they're integrated into the functionality of the motherboard itself. However, a lot of times, and most of the times, your towers, your cases, will have their own USB ports in them. And if you look on the inside of that case, along with the front panel headers, typically this is a separate wire, so we have to be careful. A lot of times you might not even see that in the front panel headers, that it's a completely separate cable, that same concept that basically plugs into the motherboard and allows you to use the USB ports that are integrated into the case versus the ones that are integrated into the motherboard. All right, so let's see, let me see, make sure I didn't miss anything here. USB, we got the power button and the power light, drive activity light indicator, and again, it flickers on and off, lets you know that the hard drive's running or lack thereof, as well as USB. So those are some of the things that we really have to look at overall when it comes to the major components within the motherboard itself. All right, now we got the fun stuff, Mike.
That's what I've been looking forward to.
Yeah, so we've been talking about a lot of the components, and what we're trying to do is just basically show you what these components are. And really, when it comes down to it, those are the majority of the major components that you might interact with on a motherboard. Some of the integrated components that you can see, the little transistors and stuff, not really anything you have to worry about for the A+ exam. However, there are some things that you do have to worry about the A+ exam, and those are known as form factors. Now, Mike, you asked a question earlier, said form factors, you know, we had size and shape, and we talked about those being the characteristics and the arrangement of the motherboards, right? This is about standardization. All right, in the earlier days of computing, everybody, and networking, and I know you're a network administrator, so I know you understand this well, everybody wanted to do everything their own way. Right. Everybody had the latest and greatest technology, but the problem is you would get into something known as vendor locked, right? Vendor locked, there wasn't vendor diversity that we have today. A lot of times, if you're just getting into computing, you don't really realize this, but there was a point in time that Atari was making computers, I think Toshiba was making computers, Commodore, and wow, that's an old one there. Yeah. But everybody was making computers, and they were all making it a little bit different. And if you bought their computer, guess what? You'd have to buy all their components too, because their components wouldn't fit in another manufacturer's components. So IBM, and again, IBM's basically led the way on a lot of things that have been standardized later down the road, right? IBM said, okay, well, we're going to release what's known as a standard or specification. Why do we want standardization? Before we even get into the form factor sizes, right? Standardization provides consistency. All right, not only does it provide consistency, it provides interoperability, and one of the great things is it allows you as the consumer to make a choice that says, hey, I can get an Asus motherboard, I can get a gigabit motherboard, But then I can go and I can go to NVIDIA if I want a network, a video card, or I can go to ATI and I can get a video card. If I need a network adapter, I could choose Intel, right? I might not even have an Intel board, and that's gonna throw you for a loop. I might have an AMD board that I could put an Intel network adapter in. Maybe I don't like Intel. Well, that's okay. I can get a Broadcom network adapter. You have choices, and you have this interoperability, and if they're following the standards, you know what to expect when you open the case. And that's one of the great things about standardization, and it's why it's important here on the exam. So we're going to talk about some of those form factors right here.
Actually, Wes, we're not. No, I'm kidding. We are going to go over them, but unfortunately, we are out of time for this particular episode. So we're going to leave you with a cliffhanger. We're going to talk about those different form factors in part 3. So thank you for that, Wes.
That's
Anything
right.
you want to add before we close this one out?
No, access denied. Apparently, we gotta leave you with that cliffhanger, but we will see you in that third part.
I like it. All right. Well, thanks everybody for joining. Hope you enjoyed watching this one. Signing off for IT Pro TV. I've been your host, Mike Roderick,
And I'm Wes Bryan.
and we'll see you next time.
Thank you for watching IT Pro TV.